Let's practice verifying inverse function. I will show you how to find the inverse function using algebra in the next video. So the first pairs of function we have is f of x equals to x to the third over 3, g of x equals to the cube root of 3x. I want to show that f is the inverse of g is the inverse of f. The way we show it is you have to show these two composite functions. So the first one will be f of g of x. We want to show that this is equals to 1. Usually it's pretty easy to show. So f of g is the cube root of 3x. So when you take the third power of a cube root, everything, the powers cancels perfectly. So this is a third power, right? And then you put a cube root inside, and then what do you get? That one gives you 3x over 3. So you have an x, and then this is a check. And then the next one is g of f. So this is a g of x to the third divided by 3. And then this is a g is the cube root, right? And then you have 3 times x to the third divided by 3. See, the 3's got cancelled. And then you take the cube root of x to the third. So you take the cube root of x to the third. Then you have an x. So this is a check. Let's do the orange one. And you have to check the f of g of x. So this is a f of the cube root 1 minus x. And then f is 1 minus x to the third power, so x to the third power, and then the third power you have a cube root in there, so everything cancels out perfectly. And then what do you have? You have 1 minus x, so 1 minus 1 is cancelled, and then this you have a positive x. And then g of f, so g of f of x, and then this is a g, f of x is 1 minus x to the third, g is the cube root of 1 minus x, so 1 minus parenthesis 1 minus x to the third. I would have to remind you that don't forget the parenthesis. So this one, let's say you do not use a parenthesis, then you are not going to get this. So it is supposed to be the cube root of x to the third equals to x. So if you miss the parenthesis, then you will miss distributing this minus to here. Then you won't get a plus, right? So this one is done. This one is done. The blue one, you have two rational function that might take some time to do. So let's start. So f of g of x. This is f of g of x is 2x plus 3 divided by x minus 1. When you do this on the quizzes, exams, especially when everything requires to be written on paper, show all your work. Don't just say, okay, we plug in, okay, that equals to x, we are done. No, I don't think you will get any credits for that. So make sure to show all your work. Okay, f of x, we have a x plus 3. So we have a x plus, this, x plus 3, and then x minus 2, right? And then you put the g in that position. So you have a 2x plus 3 divided by x minus 1, and then 2x plus 3 divided by x minus 1. Then you will have to get a common denominator on top and bottom. So that one gives you, I should use more space. So we have a x minus 1, and then 2x plus 3, and then the other one is a 3x minus 3. And then the bottom, you have x minus 1. This is a 2x plus 3, and then minus 2x plus 2. How do I get this? Let me just do this using a different color. How about using green? So that one, I have a 3 times x minus 1 equals to 3x minus 3. And then this, I have minus 2 times x minus 1 equals to minus 2 plus minus 2x. Here. Minus 2 times x minus 1, common denominator, right? Equals to minus 2x plus 2. So now you see how I got this, right? Okay, the top 2 plus 3 equals to 5x divided by x minus 1, and then divided by a fraction, so you multiply the reciprocal, And then the bottom, we have a 2x minus 2x is gone. 2 plus 3 is 5. So at the end of the day, you have an x, and then this is a check. And then g of f, so g of f. So this is a g of f of x, x plus 3, divided by x minus 2. All right, and then this one you have a lot to write. Okay, let's make the line straight. I'm going to make the line straight. And then you have a 2 times x plus 3, and then a x minus 1. So this is x plus 3, x minus 2. This is a x plus 3, and then a x minus 2. Okay, equal. So you have common denominator. The common denominator is x minus 2. So the top is 2x plus 6. Remember, distribution, right? So 2x plus 6. And then this one, you have a 3 times x minus 2. What do you get? You have a plus 3x minus 6. And then how about the denominator? The denominator, you have a x minus 2. This is a x plus 3, and then a minus x plus 2. And then in case you don't get this immediately, you have minus 1 times x plus 3. So you have a minus x plus 3 plus minus 2. Yep. Minus x plus 2. Okay. 2 plus 3. 5x, 6 minus 6, nothing, divided by x minus 2, and then you multiply the reciprocal, x minus 2. The top is a 5, so obviously that is equals to x, and then this is a check. Okay, last one. F of g of x. So this time we can write bigger, right? F of 1 minus x divided by 1 plus x. And then what do we get? We have a 1 divided by 1 plus 1 minus x, and then a 1 plus x. Okay. And then 1 divided by common denominator, 1 plus x. And then this is a 1 plus x minus 1 minus x, right? Reciprocal, 1 plus x flips to the top. And then the bottom is just what? Is plus 1 minus x, right? Did I make a mistake? G of x, here. I'm sure everybody found the mistakes. Here. G is 1 minus x divided by x. I don't know how I came up with the previous. Do you know how come I found this mistake? Because I know that if I keep going, I won't get x. Okay, this is 1 minus x divided by x. So we have to do the common denominator all over again. So the common denominator is you have x, and then this is a x plus 1 minus x. So x minus x is gone, and then you have to flip this individual x to the top, and then the bottom is just 1, so you have an x. Right? You have an x. And then how about the other one? G of f. G of f is g of 1 over 1 plus x. All right, so this is 1 minus that, and then you have this 1 over 1 plus x, 1 over 1 plus x. All right, the top, you have 1 plus x. This is a 1 plus x minus 1, not plus, minus 1, 1 over 1 plus x. I know it's a lot of work. That's why you have to practice. So the top, you have a x, 1 plus x, and then the bottom, reciprocal, 1 plus x divided by 1. There you have it. You have an x. So this is a check. This is a check. So after you prove this, f of g is equals to x, g of f is equals to x, that means you can take a look at this function one more time and say that g is the inverse of f and f is the inverse of g. So what is this x? What is this x represent? This x represents the y equals to x. It's just like the mirror. So you are looking at yourself in front of a mirror, right? So the y equals to x is equals to the mirror. So when you are touching the mirror, so when you use your left hand, so looking at yourself, you have a mirror in front of you, you are looking at the mirror and then you see your reflection. Use your left hand, touch the mirror. Now, in the meantime, your reflection is touching the mirror as well. If you take a look at yourself, let's say you are the reflection. When you are the reflection, do we agree that your reflection is holding up the right hand? So that means your left hand is touching the right hand of the reflection. If you switch hand, use your right hand to touch the mirror, then your right hand is touching the left hand of the reflection. So the y equals to x allows the function and its inverse interchange the domain and range. Or in our example, the mirror, which is y equals to x, allows you to switch your left hand and your right hand. Alright, so that is the end of this video. In the next video, I will show you how to find the inverse function using algebra. I will meet you there. If you think this is helpful, give me a thumbs up, subscribe. Let's meet you all over there.